Have you ever wondered how the universe will end? Will it collapse in on itself, tear apart into nothingness, or simply freeze over? Imagine every star in the night sky fading away forever. The truth is, scientists believe that the universe could face one of three incredible fates. In this video, we're diving deep into each of these mind-bending theories: the Big Rip, the Big Crunch, and the Big Freeze. Stay with me until the end as we explore what these endings could mean for life, the cosmos, and everything in between. Ready? Let's dive into the science of the universe's ultimate fate. To understand how the universe might end, we first need to talk about how it's expanding. Since the Big Bang, the universe has been growing larger. But here's the catch. Scientists originally thought this expansion would slow down due to gravity. However, in the late 1990s, we discovered that the opposite is happening. The universe's expansion is accelerating. This is due to a mysterious force called dark energy. Dark energy is an unknown form of energy that makes up roughly 70% of the universe, and it acts like an invisible hand pushing galaxies apart. The more space expands, the more dark energy there seems to be, and this force plays a key role in determining how the universe might end. But what are the possibilities? One of the most widely accepted theories is the Big Freeze. In this scenario, dark energy continues to push galaxies farther and farther apart, and the universe expands forever. Over billions of years, stars exhaust their fuel and slowly die out. New stars no longer form, leaving the universe darker and colder as time goes on. This results in a universe where all usable energy is eventually depleted, leading to what's known as heat death. The temperature approaches absolute zero, and even black holes evaporate through a process known as Hawking radiation. In the end, all that's left is a vast, dark, and empty expanse. Life, as we know it, wouldn't survive in such a frozen and energy-depleted cosmos. Now let's move on to the Big Crunch, which is almost the opposite of the Big Freeze. In this scenario, dark energy weakens or reverses, allowing gravity to take over. As gravity pulls galaxies back together, the universe's expansion slows down, stops, and then reverses. Over time, all galaxies, stars, planets, and even black holes collapse into each other. The universe contracts until it becomes an incredibly dense and hot singularity, similar to the state it was in just before the Big Bang. Some scientists speculate that this could lead to a new Big Bang, potentially creating an endless cycle of expansion and collapse. However, during the collapse itself, all matter and life would be destroyed. Now, here's a more violent possibility: the Big Rip. In this scenario, dark energy doesn't remain constant. It grows stronger over time. Eventually, it becomes so powerful that it doesn't just push galaxies apart, but tears them apart entirely. First, galaxies would be torn apart from each other. Then, individual solar systems, stars, and planets would be shredded. As dark energy continues to intensify, even atoms and subatomic particles would be ripped apart. In the final moments, space-time itself would be torn to pieces, and the universe would disintegrate into nothing. It's the most dramatic and catastrophic of the possible ends. While dark energy drives the universe's expansion, another mysterious substance called dark matter also plays a crucial role. Dark matter makes up about 27% of the universe and acts as an invisible glue that holds galaxies together. Unlike dark energy, which pushes things apart, dark matter provides the gravitational pull that keeps galaxies intact. However, if dark energy overcomes the gravitational effects of dark matter, the universe might accelerate towards a Big Freeze or a Big Rip. Scientists are still working to understand the exact relationship between dark energy and dark matter. But one thing is clear: these two forces are in a cosmic tug-of-war that will determine the universe's fate. Now, what if our universe isn't the only one? Some scientists propose the multiverse hypothesis, suggesting that our universe is just one of many. In this theory, new universes could be constantly forming through processes like cosmic inflation. If this is true, the end of our universe, whether through a Big Rip, Big Crunch, or Big Freeze, might not be the end of everything. Other universes could continue to exist, and new ones might be born. While this idea remains highly speculative, it opens up fascinating possibilities about the nature of reality itself and whether the end of our universe is truly the ultimate end. One of the key pieces of evidence that helps us understand the universe's future is the cosmic microwave background, CMB radiation. This faint glow left over from the Big Bang acts as a snapshot of the early universe. By studying the CMB, scientists can measure the universe's rate of expansion and get clues about its composition, including the amount of dark matter and dark energy. The CMB provides critical data that helps cosmologists predict how the universe's expansion might evolve, and therefore how it might end. Black holes are some of the most fascinating and mysterious objects in the universe. They play a significant role in how we understand cosmic evolution, but they might also be key players in its final stages. In a big freeze scenario, black holes would be the last active objects. After all the stars have burned out and galaxies have drifted apart, black holes would continue to exist for billions of years. However, even black holes aren't eternal. Over incredibly long timescales, they would lose mass through Hawking radiation, a process that causes black holes to slowly evaporate. Eventually, all black holes would disappear, leaving behind a cold, dark, and empty universe. One of the more mind-bending ideas related to the end of the universe comes from quantum mechanics. At a quantum level, particles behave in strange and unpredictable ways. Some scientists believe that quantum effects could play a role in how the universe ends, particularly in the Big Rip scenario. As dark energy tears space apart, quantum fluctuations could cause unpredictable behavior, possibly even leading to new forms of matter or energy. Another fascinating concept is the idea that time itself could end. In some cosmological models, the expansion of the universe eventually reaches a point where time loses its meaning. In a universe where nothing changes, the very concept of time might become irrelevant. Let's take a moment to reflect on a philosophical question. Why are we here now? The anthropic principle suggests that the universe is in a particular state that allows life to exist because we are here to observe it. If the universe was slightly different, if dark energy was stronger or weaker, for instance, life as we know it might not have been possible. In the context of the universe's end, this raises interesting questions. Is it a coincidence that we exist in a period of cosmic history where the universe is still active and filled with stars? Or is there something deeper at play, suggesting that the universe is fine-tuned for life, even temporarily? Now let's consider what these potential endings would mean for life in the universe. In the Big Freeze, life would gradually become impossible as stars die out and temperatures drop to near absolute zero. Without any source of energy, even advanced civilizations wouldn't be able to survive. In the Big Crunch, the contraction of the universe would destroy entire galaxies as they collapse into each other, making survival impossible. And in the Big Rip, the increasing force of dark energy would tear apart even the building blocks of matter, making life, or anything resembling it, completely unsustainable. These extreme scenarios raise profound questions about the fragility of life in the cosmos. Could advanced civilizations find ways to survive such events? Or is life just a fleeting phenomenon in the grand, ever-changing universe? The end of the universe might be billions of years away, but the questions it raises challenge everything we know about physics, time, and existence itself. So, what do you think? Will it be a Big Freeze, a Big Crunch, or a Big Rip? Let me know your thoughts in the comments below, and while you're there, don't forget to hit the like button and subscribe if you want to explore more about the mysteries of the cosmos. And let me know what space-related topics you want to dive into next. Thanks for watching.